Assalamu alaikum everyone. Welcome to Mathematics with Shahab Yaqub. So now people, let's look at different kinds of questions. And they can be from 2023, they can be from 2025. And let's focus on these. These are, I think, May, June 2025. And the focus is that whatever we have studied in P1, just a quick review before the exam. Yes, I'll be having 2-3 more sessions, and they will all be based on the recent past papers. But right now, let's get started. So now, if I open up, let's say, circular measure, something very simple. But what is the key note of this chapter? That is, in circular measure, we are talking about radians. Angle should be in radians. Calculator should be in the radian mode. And this is the conversion that you need. You don't need any fancy, what you call formulas. 180 degrees is pi radian. If you double, this gets doubled. If you halve 180, this gets halved, and so on. These three are the most important angles in trigonometry: 30, 45, and 60. 30 and 60 are related. Double of 30 is 60. Well, in that manner, you can also say 30 and 45 are related. Take 30 and multiply it with 1.5, you will get 45. Now, 150 can be written in terms of 30, 210 can be written in terms of 30, 330 can be written in terms of 30, and so on. So now over here, this is like pi by 6, 5 pi by 6, 7 pi by 6, 11 pi by 6. Similarly, 60, 120, 240, 300, they are related, and that's how they are written. Similarly, 45, 135, 225, and 315 is written, and that's how they are related. Now, what is the need of all this? The need of all this is that somewhere you come across these values, so you should be very quick. That means 3 pi by 4. So sine of 3 pi by 4 is the same thing as sine of pi by 4, except for the fact that this is in the first quadrant and this is in the second quadrant. So sine is positive in both the quadrants and things like that. Then we have this thing, the basic terminologies we should be aware of. If they are talking about a segment, this is what I'm talking about. If it's about the area, it's area of the sector minus area of the triangle. If it's about the perimeter of the segment, that is the boundaries, that is the chord AB plus the arc length AB. If they ask about the sector, that is, this is the radius, this is the radius, this is the arc length, that is for the perimeter. For the area, we have our own formula. And these formulas, they are only valid if theta is in radians. This formula we have used in O-level maths. It's still valid. If your calculator is in the radian mode, then your angle should be in radians. And sometimes they ask for exact trig ratios. Sometimes they ask for answer in terms of surds and pi and all these things. So yes, we should know all these things. So these properties also very important. These are not written in formula booklet. So they are not in MF 19. So you have to remember it. Sine of pi minus theta is sine theta. This is for like acute and obtuse angle. So first quadrant, second quadrant, sine is positive. Cosine of pi minus theta is minus cosine theta. Tangent of pi minus theta is minus tan theta. Similarly, if two angles add up to 90 degrees. So sine of one angle is equals to cosine of the other. Cosine of one angle equals to sine of the other. And tangent of 90 minus theta is 1 over tan theta. And then we did lots of different questions. The basic theme is what? The basic theme is analyzing. First, you have to develop the strategy. Are you looking for this whole length? Are you looking for this particular length? That means find this whole length, subtract from it the radius, you get this length. So sine, cos, tan, all these things, they are used over here. That is the basic theme of circular measure. So these were all the questions that we did in what you call the crash course, and of course in class also. So these are the different things. So all these PDFs are there with you. Of course, you can go through it. Right now, let me remove this circular measure thing. And let me just first add trigonometry because two, three things, they are connected together. So trigonometry is one of them. So this is P1 trigonometry. We studied trigonometry in like 5, 6 classes, I hope. And let me just double check. The last one's lecture 5. So now in trigonometry, let's get started from the basic. You are supposed to know the exact trig ratios. We already have seen that. You can get it from the calculator. But I mean, this triangle concept, you should know that if sine is given, you can find the base, find cosine, find tangent. Similarly, if tangent is given, find the hypotenuse. If cosine is given, find the opposite. And then based upon the quadrant, you can assign the positive and the negative signs. This that we talked about, complementary angles, that is very, very important. So, I mean, wherever I'll say take a screenshot, so just take a screenshot and save it so that it's again instilled in your memory exactly what is happening. So now this is one thing. Then we talked about this thing. Sine of one angle is the cosine of the other. The quadrants thing, that is about in the first quadrant, what is positive, second, third, and fourth. Of course, you know it all by now. And then in the first and the second quadrant, sine is positive. In the first and the fourth quadrant, cosine is positive. In the first and the third quadrant, tangent is positive. So now all these ratios were used. That was the beginning of everything. First quadrant, theta is alpha. Second quadrant, theta is 180 minus alpha. Third quadrant, theta is 180 plus alpha. Fourth quadrant, theta is 360 minus alpha. And then over here, these conceptual questions, very, very important. So draw a triangle, irrespective of the quadrant. It's always with respect to acute angle. And then based upon the quadrant, let's say this is about the first quadrant. So sine is positive, cos is positive, tan is positive. Some special right angle triangles that are part of our life. That is 3, 4, 5. Double of 3, 4, 5 is 6, 8, 10. 5, 12, 13 is another one. Double of 5, 12, 13 is 10, 24, and 26. So basically, this one is very important. This one is very important. So yes, there were questions like this and sometimes something conceptual. So now mark this thing that some of the things that I'm saying, that this is like, for me, it's like an exam type question that might be coming up in May, June 2026, variant 1, 2. So just take a screenshot of this. So now this one, I mean, just I have a feeling that they have not asked this a long time ago. So maybe this is one of them. And supplementary angles, we already talked about it. This was also discussed in O-level maths. And this is now being discussed in AS and will be discussed in A2. And yes, clockwise angles, very important. Clockwise and anti-clockwise. Anti-clockwise angles are positive, clockwise angles are negative. So let's say if this is 30 degrees, the difference between 30 and 360 is 330. But since you're going clockwise, give it a negative sign. And that's the general rule that we apply. If this is 150, ignore the minus for right now. 360 minus 150 is 210. Since this is clockwise, give it a negative sign. Negative angle property. That means first quadrant, fourth quadrant, all the three ratios are positive in the first, only cosine is positive in the fourth. Therefore, cosine of theta and cosine of negative theta and cosine of theta, they both have the same value. In other words, cosine of negative theta is cosine theta, but sine of negative theta is minus sine theta, and tangent of negative theta is minus tan theta. Rationalization, I think you know about it. Surds, it has everything to do with indices. The conversion, everything written in one place. Written in degrees as well as radian. Written in degrees as well as radians. Again, take a snapshot of this. Screenshot, snapshot. So let's move ahead. Sketches. Yes, sin x, the five major points, as we have studied in class, we have studied in these papers. These are the five major points. One cycle in 360 degrees, maximum occurs at 1, minimum occurs at 270. There are three zeros. Then cosine x, another five major points. But now it's starting from 1. So it's 1, 0, negative 1, 0, 1. Over here, 0, 1, 0, negative 1, 0. And then tangent. Tangent is special. So many values were taken. This red and this green, that is one cycle. Another red, another green, that's the other cycle. So now two cycles in 360. Cosine, one cycle in 360. Tangent, one cycle in 360. Tangent, two cycles in 360. At 45, it's 1. At 135, it's negative 1. At 225, it's 1. At 315, it's negative 1. And it's going from infinity to negative infinity. And then when we are solving for sin x equals to 0, sin x equals to 1, tangent x is equals to 0. So we use the sketch. Tangent x is equals to 0. Give me the same values as sin x equals to 0. Why? Because inside tan, sine and cos are hidden. So tan x equals to 0 is technically sin x equals to 0. The same for cosine. Background knowledge, quadrants, then a whole series of basic angles. Yes, again, take a screenshot that these four steps are always taken into consideration. You have to show all these steps. So no compromise on these four steps. Now let me move ahead and something like this. Now y is equals to sine kx, k cycles in 360 degrees. So k is the coefficient of x, and later on in functions, we have talked about it. This is what you call, if it's sine 2x, therefore the coefficient of x is 2, and the scale factor is half because this is stretched parallel to x-axis. If you're solving this equation, sine x is equals to 0.5. So that is like drawing the line sine x, drawing the curve y is equals to sine x, drawing the line y is equals to half. There are 2 points of intersection. When we draw y is equals to sine 2x, there are two cycles in 360. And now when we draw the line y is equals to half, instead of 2, there are 4 solutions. So all these basic things are there. Similarly, if I draw y is equals to half, still 2 solutions because both solutions are within the first 2 quadrants. Cosine kx, cos 2x, cos half x, tangent kx, 2k cycles in 360. So when the coefficient is 1, there are 2 cycles. When the coefficient is 2, there are 4 cycles. So this is red, this is green, this is red, this is green. When it's tangent half x, 1 cycle. And what else is there? Sometimes, yes, what is so special over here? Think about it. So now over here, the main thing is whenever there is a possibility of taking common, take common. That's one thing. But over here, the special thing is middle term factorization and use of this identity sine squared plus cos squared equals to 1. Let's move ahead and let's look over here. Sometimes you have to prove an identity. So you prove an identity and choose one side. Usually it's the left-hand side because left-hand side, there are more terms. You have to use identity. You have to use algebraic expansion, algebraic factorization, LCM, that's also algebra, and prove one side totally equal to the other. Sometimes it's out of the box, but usually it's manageable. And the bottom line of the story is that do not argue with a question. If something seems difficult, leave it at that moment and move on. So now this was all about expansion. So that's the original question. That's the step 1, 2, 3, 4. 5 is the cancellation, and then you get this answer. So maximum 6 steps, it's all done. And then this thing was replaced. I mean, this is what you have proven. I think so. This is sine cube x plus cos cube x. That's the answer of the first part. And then this whole thing is equaling to 9 sine cube x. So now this equals to 9 sine cube x. And then we divide both sides by cos cube. And then we get 8 tangent x is equals to 1. Tangent cube x is 1 over 8. Tangent x cube root of 1 over 8 is half. And then the 4 steps. What are the 4 steps? Quadrants, modification of range, basic angle, final answer. These 4 are always there. Sometimes you have to divide like this. Tangent can be written as sine over cos, as long as you tell the examiner what symbols are you using, so there is no harm in this. So that was the main thing, and I think that was all about trigonometry. So now let me pick some questions based upon circular measure, based upon trigonometry, and this is 2024, and this is February, March 2024. So, okay, let me just get started from the top. Okay, yes, we can focus on this thing. It says the diagram shows part of the curve with equation y is equals to k sine half x. Excuse me. So k sine kx or cos kx, k cycles in 360. So if it's half x, half cycle in 360. So now this is k sine half x, where k is a positive constant and it's measured in radians. The curve has a minimum point. So now what you have to do is that they are asking, state the coordinates of A. So from here to here, let me first work in degrees. This is 360. From here to here, it's 360 more, which makes it 720. Over here to here, that is 360 more, that is 1080. So 360 is 2 pi, 720 is 4 pi, this thing is 6 pi. Therefore, this value in the middle of 2 pi and 4 pi is 3 pi. That's one way of writing. Another way, write in degrees. So 540 is 180 into 3, 180 is pi, that is 3 pi. So 1 mark, but keep in mind 1 mark doesn't mean that this is something trivial. I mean, it requires sharpness. Take care of everything, read the question. Yes, you can think in terms of degrees, no harm in that, but the final answer has to be in radians. And this k is the coefficient. So the maximum value is k, the minimum value is negative k. Now, it's about transformation. It says a sequence of transformation is applied to the curve in the following order. Translation of 2 units in the negative y direction. So this fx minus 2 has to be subtracted. The translation vector is 0 and negative 2. And then reflection in x-axis. Then an overall multiplication by a negative sign. Find the equation of the new curve and determine the coordinates of the point of the new curve corresponding to A. So first take it down by 2 units, then multiply with a negative sign. So this is negative fx plus 2. So negative k sine half x plus 2 equation of the new curve. They are asking equation of the new curve and the coordinates of the point. So now over here, this 3 pi, the x coordinate is unchanged for right now. And then what we do is that this is k sine half x. So the x coordinate is unchanged because when you expand and when you flip, the x coordinate is unchanged. What happens to this one? Minus k minus 2 and then multiplication by a negative sign. This makes it k plus 2. So that was the special thing about it. Let me first focus on this thing. Prove that sine theta plus cos theta whole square minus 1 over cos square theta is 2 tan theta. So remember that this is binomial. There are 2 terms inside a bracket. There is a power 2. Since there is a power 2, you will get 3 terms. Another way of understanding is this a plus b whole square. That is a square plus 2ab plus b square. So that is how you get it, all the cancellation. Then it says, hence solve this equation. So now this thing over here, this thing is sine theta plus cos theta whole square minus 1 over cos square theta. That is 2 tan theta. So this is 2 tan theta is 5 tan cube theta. Now what have I written over here? Very important. That is always take common. So do not divide, otherwise you will lose part of the solution. So 2 tan theta is 5 tan cube theta. Take it to the other side, take common. Tan theta is 0. Sine theta is 0. Draw a small sketch. The range is between minus 90 and positive 90. So yes, you end up with one answer from here. The second thing, that is 2 minus 5 tan square. Tan square is 2 over 5. Tan theta is plus minus 2 over 5 square root. All four quadrants. Yes, officially it's all four quadrants, but naturally you are limited by this range. That is why that is the next step. So now in the first quadrant, theta is alpha. In the fourth quadrant, theta is negative alpha. So this is alpha taken out with a positive ratio. Work in 2 dp, final answer 1 dp. This is the first quadrant answer. This is the fourth quadrant answer. And over here, I have written all of them in ascending order. So that is a must. Negative, 0, positive. Negative, 0, positive. That is the thing over here. And I'm just looking, is there anything else to do with circular measure? Yes, this is a circular measure, and it's also a circle question. I think it's like half and half. Yeah. So this is one of the few rare questions in which circular measure and circle equation are joined. And then this was the beginning of a tradition. So now it says the diagram shows the circle with center C minus 4, 5 and radius root 20 units. The circle intersects y-axis at point A and B. So when the circle intersects y-axis, x coordinate is 0. Find the equation of the circle find the equation of the tangent to the circle at point minus 6, 9. So now we have the center, we have the radius from the center till P, find the gradient, do the negative reciprocal thing. That's gradient of PC. Gradient of tangent should be negative reciprocal. You have the point, you have the equation. So this is 3 mark, pretty basic. Now it says find the equation of the circle. So now equation of the circle, just insert the h and the k. And the radius over here, root 20 square becomes 20. Find the coordinates of A and B. So it's not necessary that you expand. You can just insert the values here. If x is 0, 4 square is 16. This is 20. Take it to the other side. The difference is 4. Y minus 5 is plus minus 2. Therefore, take 5 to the other side. 5 minus 2 is 3. 5 plus 2 is 7. So there is, these are the y-intercept. X is 0. So 0, 3, 0, 7. Of course, you know 0, 3 is B and 0, 7 is A. They have already labeled A and B. Okay, this thing is done. Now it says find the value of theta correct to 4 significant figures. Now examiner puts emphasis on both exact form as well as decimals. So you cannot compromise on that. If it's asking you to work in 4SF, then work in 4SF. So now this was the radius, this was the radius, that is the length, that is 3 and 7, the difference is 4. Apply Pythagoras, apply cosine rule and initially work in exact form because that was so easy. Square root of 20 square is 20. Now when you reach this stage and you have to calculate the angle, that is where decimals will come in. Got the idea? Make sure it's in the radian mode because it would be about circular measure. And does it say that theta radians? Yes, yes. It also says in the beginning, theta has to be in radians. Find the perimeter and the area of the segment in the diagram. I think that's too basic. So nothing special over here. So we can say that find the area of the triangle, half AB sine C. Find the area of the sector, half r squared theta. The difference is this region. And then the radius plus the arc length, that is this. So it was a nice question. So now we have done lots of question on differentiation. We have done lots of question on integration. Now let me just add this page. And I would like you people to try out this first part. Let me pause the recording. So now people, let's look at the solution of the first part, and that is worth 4 marks. Now I have written integration. Of course, it's differentiation also. Lots of indices. A power m plus n, that's a power m into a power n. And I have just written over here 4/3 plus 1/3 is 5/3. a power m into n, that's a power m raised to power of n. So x raised to power of 2/3, that is 2 into 1/3. Either 1/3 can go inside, 2 outside, or 2 inside, 1/3 outside. Just giving you an idea. And then it says the diagram shows part of the curve. X is raised to power of negative 2/3, x is raised to power of negative 1/3, x is positive. That means the diagram is also on the other side, but we are not interested in that. The curve crosses the x-axis at points A and B that you can find by making y is equals to 0. It has a minimum point at M. Find the exact coordinates of M. This 2 remains as it is. Negative 2/3 comes down. X remains as it is. Power reduces by 1. So 2/3 plus 1 is 5/3. That is what I have written over here. And I think this is for the indices part or something. So this is differentiation. Negative 2/3 comes down. Negative 2/3, negative 1, that is 2/3 plus 1 with a negative sign. And this is negative 1/3, negative 1, that is minus 4/3. Minus, minus, take care of that. Take care of any cancellation, if any. This is what you're getting. Now, when we equate it to 0, take x common, x raised to power of 4/3, or take it to the other side and divide. Yes, because over here, when we do this thing, x raised to power of 5/3, x raised to power of 4/3, we can also divide, but that 0 part is not of our concern. So x raised to power of 1/3 is 4. Cube root of x is 4/3. Therefore, x is 4/3 cube, that is 64 over 27. Now you plug in over here to find the y coordinate. Now you look over here, too much indices. Take common. So x raised to power of 1/3, x raised to power of 1/3, that is x raised to power of 2/3. So I have taken x raised to power of negative 1/3 common. And then this is 1 over cube root of x. This is 2 over cube root of x, and so on. And then when we plug in 4/3, so this cube root of x is already 4/3. So no need to write x and then take the cube root. Cube root of x is 4/3. And this makes life easier. Fractions, not very easy, but yes, it is tough in the sense that it's 4 marks and lots of working is there. So now let me go to this page and let me add a page over here. And now it says find the area of the shaded region. So now let me share these two images with you. This one and where is that equation one? This one. Let me share these two images with you in the group and try this out. So this is one page. This is the other page. And it's over here. This level. Now try out the other part. That is about finding the area. And I can just show you this part also. So this is finding the area between A and B under the graph. Shaliji, Bismillah. So now people, this particular question, the second part is find the area of this shaded region between these two values, A and B. So now over here, first thing first, that's the equation. The curve cuts x-axis, therefore y coordinate is 0. 2x raised to power of minus 2/3 minus 3x raised to power of minus 1/3 plus 1 equals to 0. It's a disguised quadratic equation because the power, the highest power and the second highest power is in a ratio of 2:1. So let m is equals to x raised to power of 1/3. M square is x raised to power of minus 2/3. So this is 2m square minus 3m plus 1 equals to 0. Show all the factorization. Do not compromise on this. Read the examiner report over and over again. You have to show the working. There are two values of m. This is 1.5. But m is x raised to power of negative 1/3. So 1 over cube root of x is 1. Cube root of x is 1. Therefore, x is 1. 1 over cube root of x is equals to half. Therefore, cube root of x is 2. Therefore, x comes out to be 8. So one answer is this is 1 comma 0, this is 8 comma 0. So basically plug in the limits between 1 and 8. So now over here, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power. And uh, this one over here is 1 and it should have been x. So maybe there was a small mistake over here. So this should become x and then we plug in the limit. So I think I forgot to wrote x, but then I worked it out. So this one becomes x over here. So let me write it down. This green one, that is x, that is x. That is why we have the value 8 and we have the value 1. And then you simplify, and then the final answer is 0.5. Yes, it comes out to be negative because it's below x-axis. Just discard that negative sign. Now let's focus on something like, okay, that was the last question over here. Let me go up. Let me focus on integration with limits in which there is this theta. So there were 2 or 3 questions that they have asked till now, which involves theta. And first of all, this is just a simple integration. Of course, you have to take it up. 2x raised to power of negative 2 dx, increase the power by 1, divide by the new power. This is negative 1 over x. Now it's your choice. If I want to remove this negative sign, then these two will change places. So negative is there on the outside. I did not. If I want to remove it, I can write 1 over x and theta will go down, 3 will go up. That's your choice. There are questions in which I have taken common. There are questions in which I have not taken common, so that you have a variety of working. So this is 1 over infinity minus 1 over 3. Any number divided by infinity is 0. So this thing becomes 0. And minus 2 into minus 1/3, that's plus 2/3. That's the special thing. This we already talked about. Another question of integration. Now, sometimes they have more integration than usual. Sometimes they have more trigonometry than usual. So there is no set rule. Sometimes it's a balance paper also. So a curve is such that dy by dx is 3 bracket 4x plus 5 raised to power of half. It is given that the point 1, 9 and 5a lie on the curve. Find the value of a. So now this is the gradient function. You need the equation of the curve, integrate. This is to be done using chain rule. First simplify, then plug in the values. Once it's simplified, now plug in 1 and 9, evaluate C. And that's the equation of the curve. And the next point is 5 comma a. That means when x is 5, the value of y is a, and you evaluate. So sometimes you get a non-traditional answer. Sometimes you don't expect that the answer will be so big, but just trust your working. We talked about this thing. Another thing, but this time this is differentiation. A curve has this equation y is equals to 3 over 2x square minus 5. Find the equation of the normal to the curve at the point 2, 1. Give your answer in the form such and such. Now this is coordinate geometry. This is differentiation. So now y is equals to 3 bracket this thing raised to power of negative 1. Differentiate. In differentiation, there is no limitation of what's inside the bracket. Plug in the value of x is equals to 2. This dy by dx is gradient of tangent. Equation of normal is negative reciprocal. People ask this question, should we write something like this? That gradient of normal is negative reciprocal of gradient of tangent. Yes, it's a good idea that you can write it. Show all the working. Do not leave the working as it is. You have to continue. When you continue, you have to write exactly in this form. So this is ax plus by plus c or d equals to 0, and that's how the constants are obtained. A binomial, something easy, but don't take it for granted. Now it says when these two brackets are multiplied, the coefficient of x cubed is 432. Now the main thing is there is a constant term 0 over here. There is an x term 1 over here. That means from this bracket, which two terms do you need? So you need an x cube that will multiply with the constant. So overall will be x cube. You need a power 2 term, a quadratic term that will multiply with x power 1. That will give you x cube. So in binomial, we are not basically just solving questions. We are just memorizing, writing it down. What are the main things over here? And yes, I will also list it. So find the value of the constant a. So first find the x square term. You know how to find it. NCR, success, not success. This is not S1. This is the second term raised to power of 2, first term raised to power of 2. Then x cube, 4c3, second term raised to power of 3, first term raised to power of 1. Then you multiply it selectively, the blue with the blue, the green with the green. Take care of the coefficients, add it up, equal it to 432, solve, and then you get this answer. And this one, quadratics. So let me do two more questions and then let me add a page over here. That is like a review page. So let me write over here. So this is P1, last minute pointers that we need. Let me just create this. Okay, let's increase this thing. Okay, so now where were we? Okay, here. So now over here, it says the straight line y is equals to x plus 5 meets the curve such and such at a single point. What does it mean? It means tangent. So you have to understand the vocabulary. Okay. And then it says, find the value of the constant k. Make a single equation. So this is 2x squared plus 3y squared is k. So instead of y, write x plus 5. Don't forget to square it, expand, simplify, take all the terms on one side. Now, in quadratics, in circle equation, in differentiation, in integration, you cannot skip algebra. You have to be very, very extra careful. Yes, mistakes happen. Mistakes do happen. Just a slight, what you call relaxation thing, and things will go wrong. So now this is 5, this is 30, this whole thing is c, b square minus 4ac, and it so happens that you end up with a linear equation. Maybe it can come out to be quadratic, maybe it can come out to be linear. Find the value of constant k. The second part, it says find the coordinates of P. So now plug in that value of constant k. This is what you get. Factorize. Of course, you will only get one answer. You will get the value of x, plug in the easy equation, that is the line equation, that's the value of y. Line is tangent to the curve, b square minus 4ac equals to 0. In other words, when we talk about this thing, x is equals to minus b plus minus b square minus 4ac, the whole thing over 2a. So this thing is 0 because this is that tangent thing. Okay, so what am I left with? I'm left with negative b. I'm left with 2a. So negative b over 2a, you can also write it directly. So this is after the simplification. So without the simplification, this is b, this is a, use it, and then you also find the value of x. And of course, then you can find the value of y. Arithmetic progression. We have this thing. The first term is 6, 10th term is 19.5. Find the sum of the first 100 terms. So first you have to find d. Then you have to find the formula. Nothing special. A geometric progression is such that the first term is 24, common ratio is half. The sum to infinity is denoted by s. The sum to infinity of the even numbered term is denoted by se. Find the values of s and se. Again, nothing special. So now over here, the first term is 24. Common ratio is half, 24, 12, 6, 3, 3 over 2, 3 over 4. Now pick the even numbered term. So now the first term is 12. The common ratio between these two is 1/4. Original one, first term is 24. Common ratio is half. Find the sum to infinity. Find the sum to infinity. Functions. Yes, functions is important. The functions f and g are defined for real values of x by such and such, where k is a constant. Given that the range of this function is this much, find the value of k. So g of f of x, that means fx goes inside g in place of x. That is 5 of fx minus 1. Write it down, simplify, and over here, take the 39 on this side. So now I could have also done this. That I could have, this is already in the completed square form, almost, but there is a 3 over here. So therefore, I first focus on this 3. That is 3 bracket x minus 2/3. Focus over here. There is a square on the outside that applies to this and applies to this. And then once this is done, then I took 39 to the other side. So this is x minus h whole square plus k. This big K is this whole thing. Now it says, find the value of k. So find the value of k. That means this a is positive, h is 2/3, and this k, 5 minus k, should be greater than or equal to 0 because it is above the x-axis. So now over here, this whole thing is greater than 39. That means this whole thing is positive. This whole thing positive means the y-coordinate should be above the x-axis. And over here, 5k minus 40 and k is greater than or equal to 8. Also, we can say that if this thing is greater than or equal to 39, so there is a line over here, 39, y is equals to 39, and this y-coordinate should be above this thing. So any which way, we find this value. For this value of k, determine the range of fg. So this is f of gx. I think the first one was g of fx. This is f of gx. Again, we have something like this. Again, we do all the completed square form, and then by drawing a sketch, we get this thing. Now, this thing over here, this is the most tricky part, even though it's for 2-3 marks. But yes, we should know this concept. That is, the function h is defined for all real values of x and is such that g of h of x is 35x plus 19. So what is hx? Find an expression for g inverse, hence or otherwise find an expression for hx. So now this is gx, this is g inverse. Now the rule is GHX means first h, then g. First g, then first GH, then inverse. So now we are going this thing. And then if we do the inverse of g, I should be able to get this thing. So now this was a new kind of a concept. So now hx is g inverse of gh. So first gh, then g inverse, going this way is g inverse. So just take the composite of these two and you find hx, and you can double check by plugging in the value. So first h, then g, that's gh. But h is basically gh into g inverse. So that is the kind of working. Keep in mind, this is February, March 2024, variant 1-2. Now, such a small question, not very less marks, but still, if something like this feels difficult, skip and come back to it at the very end. I think the rest of the questions we have already done. So now let me write down the main pointers that you have to look for. So let's go to each topic and let's categorize. So if I talk about quadratics and functions together, so when we talk about quadratics and functions together, so the key player is b square minus 4ac. The key player is completed square form. The process, show all the working, and the sketch. The key player in these two topics is the factorized form, because based on the factorized form, you have to solve the quadratic inequality. Remember, sketch is a must. So don't compromise on these basics. Sketch is a must. That's one thing. What else is there? When we talk about functions, we talk about domain and range. And again, domain and range has to do with sketches. Then we can talk about transformation. Transformation take care of everything. The sketch, the pointers, the points, the order of transformation, and what else? What happens if it's a vertical transformation? What happens if it's a horizontal transformation, and so on. So let me just do one thing. Let me grab this functions idea and let me show you that image. That is this thing. So now over here, when we talk about combination of transformation. First, understand there are three vertical transformation. The purple is for vertical and the orange is for horizontal. Reflection in x-axis because it's going like this. Translation along y-axis and stretch along y-axis. So y-axis, but reflection in x-axis, that's vertical. Similarly, translation horizontally, stretch horizontally, and reflection in y-axis, that is horizontal. When combining transformations, the order makes a difference. Now, let me just grab this thing. Let me add a page over here. And then look over here. When two vertical transformations are combined, when two vertical transformations or two horizontal transformations are combined, the order in which they apply may affect the outcome. So assume that the outcome will be different. Maybe it will come out to be the same. Just think of it this way. When one horizontal, one vertical transformation are combined, horizontal and vertical. So this is vertical, this is vertical, this is horizontal vertical or vertical horizontal. So now the order does not make a difference. So these two are exactly the same. Vertical transformations follow the normal order. So vertical transformations, they follow normal order. And similarly, horizontal transformations, they follow opposite order to the normal order of operation. Now, what does it mean? Let me show it to you. Now, these were some of the basic things that we did. Let's focus on this. It says, let's say I want AFX plus K. So plus K, that is a translation parallel to y-axis. If it's positive, will go up, negative will go down. And there is AFX. So now AFX, that A means stretch parallel to y-axis. So stretch vertically, factor A, multiply function by A. That is the normal order. And then translate, add K to the function. So translate it parallel to y-axis, and that's the translation vector. Now, when we are combining two horizontal transformation and we want F bracket Bx plus C. So now Bx won't happen first. First C will happen. So now translate minus C0 plus C means negative. That's the rule of horizontal thing. Replace X with X plus C. And stretch horizontally factor 1 over B. Whatever is the coefficient of X, the scale factor is 1 over B. So now keep this thing in mind. This is more detail of that. Take a screenshot if you have to. So now transformation, yes, it's kind of tricky. If someone feels it very, very tricky, try this question at the very, very end. A basic question like this. You see that these two are being transformed. One single transformation, that is reflection in y-axis. So there is a negative sign over here. Over here, some people think that movement has taken place. And let's see, this is 1, 2. This becomes 1, 4. So 1, 2 becomes 1, 4, or 2, 1 becomes 2, 2. So only the y coordinate is changing and the y coordinate is doubling. So the stretch factor is 2. Since only the y coordinate changes by a factor of 2, so the stretch is parallel to y-axis, scale factor 2. It's not stretch plus translation. It's one single transformation. Also, you can see that the difference between this point and this point, this vertically is 2 units. And from this to this, now the vertical difference is 4. That also confirms, yes, it's a stretch parallel to y-axis. Over here, it's moving to the left and moving down. Solid is the original one. Dotted is the transform one. That is how the transformation is taking place. Something like this one. The graph of y is equals to fx is transformed to the graph of y is equals to 2fx minus 1. So one is a horizontal translation. The other one is horizontal transformation. The other one is a vertical transformation. So first order as such does not make a difference. So first translation vector 1, 0, and then stretch parallel to y-axis, scale factor 2. So this thing on the outside, that's the scale factor. Then it says the curve is reflected in the y-axis and then stretched by a scale factor of 1/3 along x-axis. So 1/3, if this is the scale factor, therefore the coefficient of x should be 3. So now the curve y is equals to sine 2x minus 5x. This thing, first replace x with negative x because it's reflected in the y-axis. You get this thing. And then what is happening is that this x will now be replaced with 3x, and then you write it like this. And how did you get this minus on the outside? That is this rule. Sine of negative theta is minus sine theta. So now coming back to this, transformation, sketch, points, order, writing things down. That is, you have to describe the transformation. So let's say if it's reflection, you describe this is in x-axis, the reflection is in y-axis. That is more than enough for reflection. When we talk about translation, so we say parallel to x-axis, and then we have to give the translation vector. Parallel to y-axis, and then we have to give the translation vector. If it's about this thing, which is a stretch, again parallel to x-axis, again parallel to y-axis, then you have to write the scale factor, then you have to write the scale factor. So now just a quick overview. When we have y is equals to afx, that is parallel to y-axis, y equals to afx, that fulfills this criteria, scale factor is a. When it is f of ax, scale factor is the reciprocal of the coefficient. Keep that in mind. And over here, if it's translation parallel to x-axis, so this is fx plus minus h. So plus means left, minus means right. And over here, fx plus minus k, plus k means up, minus k means down. That is the basic thing that you're aware of. So that's more or less quadratics and functions. And then if I talk about this thing, that is circular measure, trigonometry. So whenever radians is required, make sure calculator is in radian modes. If it's required about degrees, so radians, circular measure, no compromise. Degrees, it could be in trigonometry, and radians could also be in trigonometry. We have to sketch the idea. Identities, I talked about it in the beginning of the class. Equations, then follow all the 4-step procedure. Then conceptual questions. What do you do with the conceptual questions? You draw a triangle. You use Pythagoras theorem. You have all these things, that is sine of 90 minus theta type of identities. We have sine of 180 minus theta type of identities. We have sine of negative theta type of identities. So we should be aware of all of this. We should know how the exact trig ratio works. That is very important. So that is circular measure and trigonometry. Now, if I talk about, let's say, coordinate geometry, we know line is something very easy. And then there is circle. Yes, in line, there is a very important property that comes very rare, but of course, it's part of the syllabus. Tangent theta equals to gradient of the line. And then we used to find the 3 cases, angle between 2 lines. So angle between 2 lines, let me see if that thing is here, coordinate geometry line. We did it in 3 classes. There it is. Okay. So now the first thing, slope and line, tangent theta equals to gradient of the line. Theta is the acute angle that the line makes with x-axis. If it's making, if it has had, my bad. If the gradient is negative, ignore the negative sign and calculate the acute angle. And then we apply this concept over here. That is, if both slopes are positive, calculate angle that each line makes with the horizontal and subtract. That is to find angle between two lines. If both slopes are negative, discard the negative sign, and work as if this is case number one. If one slope is positive, the other is negative, of course, finding the angle, discard the negative sign, add both of them, subtract from 180. So that is the basic rule that is over here. So now that is what I was referring to, circle. So now we are back to quadratics. Again, b square minus 4ac. Of course, the completed square form. To get it into the form x minus h whole square, y minus k whole square is equals to r square. And hold for a second, let me show you one other thing. So now the circle one, that was not there. So this is CG circle one. Okay. So now over here in circle, we went through all these examples from here. That is how the circle equation was formed, the basic idea. And then we talked about the comparing coefficient. Then we talk about if center is given, radius is given, how do you write the equation? Do not open up the brackets. There is a point on the circumference. There is a center. Find the radius, find the equation. General form to the completed square form. That's an example. Make sure the coefficient of x square and y square is 1. So write the x square with the x term, write the y square with the y term, and the rest of the history, you know it. Then this thing is done. Show that the circle passes through the point, plug in x and y, and the both sides should be equal. If the diameter is given, how do you find the center? You find the center, you find the distance from center to one of the endpoints, that's the radius, and then you write it out. Circle geometry, all these properties are necessary. The diameter makes a 90-degree angle at the circumference. Radius is perpendicular to tangent at the point of contact. Chord bisects the distance, the line from the center to the chord bisects it equally. And if you need the radius, this is the radius, this is the radius. Equation of tangent, you need the center. You need the gradient from center to this point, negative reciprocal, that's the gradient of tangent, and then equation. Something like this, all these things. So many questions that are there. So now let's remove it. That was about this thing. So now circle properties that is needed. Then lots of algebra. Algebra in expansion, algebra in simultaneous equation, in which there is a line, there is a circle or a quadratic thing. So that thing is there. Algebra in b square minus 4ac, algebra in middle term factorization, algebra in quadratic formula. And then, of course, basic coordinate geometry of line, that is the equation of a line. Maybe we talk about coordinate geometry thing, distance between 2 points. We should know how to sketch a triangle. Maybe this is a center, there is a point A, there is a point B, and use this as the base and use this as the height, not necessarily isosceles, and then half base into height. And these are the basic kind of things. Yes, trigonometry. So trigonometry, Pythagoras, sine, cos, tan, sine rule, cosine rule, area of triangle, half A, B, sine C, the same kind of thing that you have used in what you call circular measure also. So we talked about circular measure, trigonometry, coordinate geometry, quadratics, functions. Let's talk about series. So series has 3 components. One of them is AP, the other one is GP, the third one is binomial. So yes, we did few questions of binomial, few of AP, few of GP. You need the formulas very thoroughly. You need to understand in AP and GP whether we are talking about the term, whether we are talking about the sum, and specifically in GP, if sum to infinity, an infinite series, has a finite sum. What it means is that, let me just double check one thing, that is the recording. Yes, it's all good. So now an infinite series has a finite sum. That means sum to infinity applies, a over 1 minus r, and common ratio lies between -1 and +1. So this is called a convergent series. Convergent series means sum to infinity means it's part of GP, nothing to do with AP. And what else is there? There are questions related with trigonometry and sum to infinity. Keep that in mind. What else is there in AP? A common difference, that is T2 minus T1, that is T3 minus T2, and so on. Over here, common ratio, that is T2 over T1, that is T3 over T2, and so on. So these are the kind of basic things. Yes, sometimes the word problem type of thing, they do come. So word problem, so just read it very carefully and then try it out. And then last but not the least, that is differentiation, that is integration. So now in differentiation, what do we have? We have the basics, the basic differentiation, the chain rule differentiation. Then we have coordinate geometry questions, gradient of tangent, gradient of normal. Gradient of tangent is dy by dx. Gradient of normal is there. I have also shared a video of first principle, a very, very basic concept, a 10-minute video. Do watch it. Then we talk about rates of change, the dA by dt, the dA by dr, the dr by dt. So these kind of things. Then we talk about stationary points. So in stationary points, dy by dx equals to 0. And then nature, that is the second derivative, d square y over dx square. If it's positive, it's a minimum. If it's negative, it's a maximum. And when they ask maxima or minima of anything, derivative of that anything equals to 0. That means if they ask this for the gradient is a maximum. So therefore, derivative of gradient function equals to 0. That means derivative of dy by dx is equals to 0. So this is very, very important. Yes, they have asked questions like this. So right now, let me just remove this thing. That is more or less the thing. Yes, and one other thing that is over here in stationary points. That is that application thing. It comes very rare nowadays, but of course, they can ask you something about 2D mensuration, that is perimeter and area, something about 3D mensuration, that is surface area and volume. Then they can ask something about similarity. They can ask something about graph and coordinate geometry. They can ask something about circular measure, which technically falls under the category of 2D mensuration. So first prove and then work it out. So that is differentiation. And now if I talk about integration, so again, the basics of integration, again, the chain rule, and chain rule is only valid for a linear expression. For anything else, you have to expand it. What is common between these two? All the powers are good, but n is equals to -1. That's not possible. Then we know that dy by dx, when we integrate it, we get equation of curve plus a constant of integration. We plug in x as something, we plug in y in something, and then we find this thing. Then we talk about area. Then we talk about volume. Area can be a simple area Area can be between area. Area can be a separate area. The same thing goes for volume. So the same thing that's written over here, simple, between, and separate, that also comes out to be for this thing also. Now the formula for area, that is area under graph, that's very simple. Area is basic integration. This is A, this is B, this is fx, this is dx. This is with x-axis. If it's C and D, and this is f of y dy, this is with y-axis. But if it's volume around x-axis, that is pi, limits a and b, this is fx whole square dx. If it's volume around y-axis, that's again a pi, c and d, and that is f of y whole square dy. So now just recently we finished this thing. So let me just show you this thing over here. The second lecture was totally focused on this thing. That is this idea from here. This is area under the graph with x-axis. Basic integration, limits on x-axis. Area under graph with y-axis. So now you rotate it. That's under the graph with y-axis. And then when you plug in the limits, C cancels off. Upper limit first, lower limit first, a lower limit second. Simple area, you can also use 2D mensuration, triangle, rectangle, square, trapezium, if you want. Otherwise, integration is always there. Now, this is y is equals to 2x. This is y is equals to x squared. Now, join the two. That's area between two graphs. The top one has more area. The bottom one has lesser area. Calculate it separately and subtract. This area below the x-axis will come out to be negative. Just discard the negative sign. Area under two separate curves. The red area is under the line. The green area is under the curve. Evaluate it separately. Separate limits. And if they're asking for the total, add it up. If they're asking for the ratio, divide. Improper integral, where infinity is involved. So if I integrate this function between 1 in A and 1 in B, so if A becomes very, very small, almost zero, the area is undefined. If B becomes very, very big, almost infinity, so B is over here, that's almost infinity. So what will happen? 1 over infinity will become 0. 1 over 0 will become undefined. So the irony is A was 0, but the area is undefined. And B was undefined, but the area is finite. Volume, first square, then integrate, plug in the limits. Don't forget to multiply by pi. That's a formula that I just wrote. That's a formula that I just wrote. There are no options. If they say revolve it around the x-axis, revolve it around the x-axis. Volume under the line, yes, I can also use the cone formula, but I would not like to because people then get confused between the radius and the height and mess up the whole thing. Waste pages, waste lines, waste your ink, but don't compromise on your marks. Don't waste your marks. So show every single step. First step, just simple squaring. Second step, integration. Third step, taking common. Then plug in the limits. Then evaluate. Again, y is equals to x square. X square square, that's x4. Then integration. Then common. Then limits. Between the two, a no choice, examiner will mention the axis against which the region is revolved. Volume produced by the line, volume produced by the curve, subtract, you get the answer. Leave the answer in terms of pi. The same question that we use for area, now we are using for volume. First, you have to square. Chain rule is not applicable. So over here, chain rule of integration is not applicable as x squared minus x is not a linear expression. As simple as this. So this is A, this is B, this is A squared minus 2AB plus B squared, and then integrate each individually and then plug in the limits. Volume will always come out to be positive. Volume produced by two separate graphs. Find the volume of each separately. The areas were coming out to be the same. Now look over here. The volumes are coming out to be different. And what else? So basically, that's about it. And inshallah ta'ala, I'll be uploading some more lectures of October, November 2025, the other variants very soon. So stay in touch and take care, everyone. Allah Hafiz.